liquid nitrogen and liquid helium. This is liquid nitrogen tank. 1000 liter tank. This is liquid helium cylinders. Nitrogen we produce from air because air contains 78% nitrogen. We just cool it with a special machine and form a liquid nitrogen. It can be stored here, and these are the small lab level device. So whatever I was telling you, these are the walls, pressurizing wall, liquid wall, and here is a pressure gauge wall. These are cryogenic gloves. It is more insulated, but if we dip in directly in cryogen, it will become hard, and it is still danger to contact directly. So how the liquid nitrogen looks like? In case of high pressure or low temperature, we have to open wall gradually, slowly.
Oh!
While filling the container, you have to insert till the neck. Otherwise, if we open in air, it continuously evaporating. It doesn't collect. So this is liquid nitrogen. Colorless, odorless, tasteless liquid. Temperature is how much? Minus 196 degrees Celsius or 77 degrees Kelvin. So at this temperature, many miracles, many interesting science happens. So now we'll see experiments other than seeing safety part. Are you ready to do with me?
Yeah.
Yes.
Let us start with giving flower, offering flower. Any any boy volunteer?
Video করছি video
Now forget about serious science lecture. We'll do it funny way. आपका नाम क्या है? आशुतोष।
हाँ वो इस कैंटीन से लेफ्ट लेना और फिर निकल के राइट लेना फिर से निकल के फिर राइट हाँ जैसे निकल के सीधा जाना
आराम से ब्रो ओ
Hard and brittle in liquid nitrogen.
बाहर
तो soft leaves, नरम पत्ते हैं, नरम। मैं dip कर रहा हूँ। I'm dipping inside. It just become hard like पापड़।
पूरी
बिना सेके तले पापड़ बन जाते हैं। अभी ट्राई करें। Soft leaves है, अंदर डालते हैं। Just hold for some time, again it will become softer. Yeah. We have more, we will. Everyone gets So you can powderize anything.
अरे भाई उसको दे पीछे
Powderize anything with liquid nitrogen or cryogens. Okay. For sintering process, you need 5 powders. We can powderize with liquid nitrogen. Any rubber powder, chili powder, rose powder, polythene powder. Even you can put a hand and make a powder.
लेट्स ट्राई दैट
Plastic tube, flexible tube. If I dip inside, you can see nice fountain is coming out. Plastic tube, कोई जादू की छड़ी नहीं है. अंदर डालो एक अच्छा सा फाउंटेन आने लगता है. Can you see?
फुलझड़ी
Some fountain is coming out. Any guess why this happens? ऐसा क्यों होता है? Plastic tube. कोई जादू की छड़ी नहीं है, जादू की ट्यूब. अंदर डालो.
प्रेशर टेम्परेचर
गेस करेंगे क्यों हो रहा है?
There is a high pressure.
हाँ?
प्रेशर
Atmospheric pressure. Capillary, for capillary you need a fine diameter. This is quite big.
टेम्परेचर गेज
So it is not capillary.
प्रेशर गेज टेम्परेचर
Huh? But pressure is same. It is not. Okay. You know what is this temperature? Room temperature. What is this temperature? -190. So this is very cold. This is very hot. When we dip this hot tube, it will evaporate liquid. When liquid evaporates, its volume gets increased and pressurized. Huh? After some time it will not. So when we dip tube, it creates fountain. After cooling down the tube, fountain stops. Okay. Slowly fountain reduced and stop. If I put this end, again fountain will start on cooling voltage. Fountain will stop. Again plastic tube. Again plastic tube, flexible tube. If I dip inside, it just become hard like glass. It just become hard like glass. It become hard like glass. I can cut anything with this. This is very hard, very sharp. You can cut anything. But after some time, again it will become softer. Even with water, you can make ice knife. पानी से आप चाकू बना सकते हैं. Have you heard ice knife?
हाँ
सुना है? CID में. But ice का knife बनाओ, पानी का knife बनाओ, बटन करो, भाग जाओ, ice will melt. No evidence.
नो मिलू का
How many of you are in physics and chemistry, mathematics?
They were not in
नो
Air balloon. Just guess, if I dip inside, what will happen?
It will shrink and become harder.
Air balloon. When we dip inside,
प्लास्टिक
become fat. When the air gone, हवा किधर गई? It is condensed. Can you see liquid at the bottom?
Yeah, that's condensed.
Air condensed.
Reform.
Liquid at the bottom. You can see liquid evaporated. Now you can see some powder-like thing. You can see some powder, right? Just watch at this powder. It is also reducing. So powder भी reduce हो रही, कम हो रही है. You can see powder, no?
Yes.
You can see some solid particles. Carbon, dry ice. Okay. First we have seen liquid air. Liquid, that was air. Whole balloon, something 3-liter balloon, is condensed to only half ml, 1 ml, 1 ml of liquid, right? Then liquid evaporated and balloon get inflated. Then we see some powder-like thing, some solid particles that directly went to gas. Means that sublimated, right? So that sublimating material was dry ice, carbon dioxide. Carbon dioxide doesn't have liquid phase at atmospheric pressure. It directly going from solid to gas. It is sublimating. It is not melting, that is why it is called dry ice. Okay, why this balloon is totally flattened? Because any gas, when converted in liquid, its volume drastically reduces. In case of nitrogen, the ratio is 700 times. If I take helium, the ratio will be 800 times. So, storing the large volume of gas is most efficient in liquid phase. Okay. Any volunteer? Strong volunteer? All, आजाओ, दोनों आजाओ. We'll do again. Okay, we have a paper. Fold it half. Again fold in half. And fold 3 layers in your piece and
ठीक नहीं भेजा.
okay. I will take liquid, some दोनों हाथ से पकड़ो. I will take some liquid. Can you see the liquid level? Level is almost steady. Level is almost steady. But something is dripping down continuously. You can see level.
Okay.
Level is not falling that much. There is some evaporation, but so you can see liquid level is almost steady, but something is coming down continuously. You can touch it, but just touch and hold. Touch and leave. Don't hold for a long time, otherwise it will make a nice hole on your hand. Just touch and leave.
कुछ नहीं हो रहा.
Is your hand get wet? आपका हाथ गीला हो रहा है?
That is not cold, no?
हाँ, गोल्ड भी नहीं है.
Touch
Not
and
even
leave.
cold.
ये कम है.
Try.
Your hand is not getting wet. So it is not water. Right? Now let us see, is there any hole in paper or not? Just dump it. You can see still liquid is there. Your hand is not getting wet. Any guess what is happening? क्या था? Air. Air. Okay, this is liquid air. Outside one is liquid air. Whatever air is coming in contact of cold coal, it is condensing and dripping down continuously. We feel something is coming down from bottom point, but it is not inside liquid nitrogen, it is outside air. जैसा हम फ्रिज से बॉटल निकालते हैं, जो बॉटल के सराउंडिंग में विल सी मॉइस्चर ड्रॉपलेट. At this temperature, air become droplet. When we dip balloon inside, what was happened to air? It become liquid. So all air is condensing at the surface, cone surface, and dripping down. But in science, any result we see with some other method. So let us open the paper and see, is there any hole or crack or not? Just check, is there any hole or crack? No hole, no crack. Means whatever we see seen has outside air. Okay. Shall we continue or you are got?
Continue. Always this is empty.
As we know, when liquid evaporates, its volume gets increased by 700 times. If we take it in closed vessel, volume will be equal to vessel volume. Then what will increase? Pressure, right? So I am taking some liquid in cooker, closing the lid. Immediately pressurized. Khana ready. So it gets very high pressure. We can run high-speed turbine with this. This is the volume. You can see cold cooker is dripping. What will happen? Whatever pressure created, it will not release, so it will enough to blast the cooker. So second, cold cooker is dripping. Second. You are touching whistling cooker for first time. Don't try at home.
नाइट्रोजन नहीं मिलेगा. ठंड है भाई, बहुत ठंड है. ये मिलेगा लिक्विड नाइट्रोजन
कुकर पे मिल जाएगा. बंद हो गया.
प्रेशर कम हो गया. हुई.
You can make instant ice cream with liquid nitrogen. Just within half minute we can freeze ice cream. Shall we try?
Yes. Yes, green. That will be green. That will be nice.
Anybody made ice cream at home?
Yes.
Yes. How much time take to freeze ice cream?
Depending on fridge,
Shall we wait for 4 hours?
fridge temperature.
We'll make instant ice cream.
Yes.
What is necessary for ice cream?
Milk,
I made one polythene cone. We'll take some milk.
पूरी मिर्ची जुगाड़ करके
What is
रखा है
next? आगे क्या? शुगर
हाँ
अभी डायबिटीज का जमाना है तो शुगर फ्लेवर्स करते हैं. So we'll dip in our new fridge, cryogenic fridge. Shall you count the time? Huh? So start. 1, start.
3,
45 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26
Natural ice cream. Very cold. Anybody want to taste?
taste
Taste slowly. Yeah? It is very cold. Taste slowly.
I don't
Para
really
kya
want
bhai?
to taste this. No, it is milk, but I. Hey, give it. I'll play with it.
I will also play with it.
You took half, no?
Slowly.
जीभ अटके है भाई अटक जाएगा भाई सीरियसली इसमें अटक जाएगा
इधर मत लो ना.
नहीं जीभ में दिया था अटक गया था
I don't know. It just
टेस्ट तो नहीं है
अच्छा. Have you put a nail in wood or
Yes.
wall? What tool you are using for?
Hammer.
I don't have hammer. I just tell you, just take a banana. Can you do it? Can you do it?
हाँ हाँ
Yes.
Huh?
Yes.
How?
Harder.
पूरी टन
Dipping in that. Anybody want to try? आगे नहीं आप तो आगे आप आगे banana. Is this normal banana? Yeah, nothing made up of iron or steel something. No? Normal banana. Eatable. So what we have to do? Leave it. It will take some time.
वीडियो तो बैक
It will take some time. Meanwhile, we will say something else. Oh, white car. White car है. White.
Oh.
Any guess?
No.
the inner color
Huh?
two coated
White. Why it become red?
oxidation
Huh?
It's
Color
like.
changing.
Okay, color
There are
changing.
some
that.
colors which are changing its shade according to temperature.
According to
That
temperature.
color is called thermochromic color.
Yes.
Okay? This car is painted with thermochromic color. That is why it is change color. It may rub it back.
Temperature. Okay.
Something else. You have to go for lunch, no?
we have time I think
One conducting demo is there, but I don't know. It will take some time to
Yeah, sure.
it's
Sure.
okay
Sure.
cool
Sir.
down. I don't know if we will get that much time or not.
we are okay
Let's try. it works, then fine, otherwise.
Okay, we'll cool it.
It is just
Yes, yes, yes.
getting up to see Okay, let's take our new hammer, banana as a hammer. Will it become hard? Can we try it?
Yes.
So try with our new hammer, so-called hammer, banana as a hammer.
Don't break the banana.
We actually want. Okay, fine, enough. So it is really hard. You can see our new hammer.
कितना देर तक हार रहे
Smash it down, it will break. We will smash it. We will smash it.
Dream come true, okay?
Smash it.
No, no, don't smash it. Let everyone see it. Let everyone see it then. Oh, it's not. Okay.
It is.
No, no.
No,
That's
that
it.
part
That
was
part
not
was
it.
not. I'll smash it at last.
Hey,
I want to smash it.
you will smash it
She
or
smashed
no one
my
will?
flags. Umar.
वो भी जुड़ जाएगा पकड़ना था तोड़ना नहीं था
वहाँ देखा था दिल्ली में NPL है.
Okay. Large quantity of cryogenics are used in space. Once we go to space, the temperature is cryogenic temperature. Okay, something 3 Kelvin to planet radiation or sun radiation temperature. But it is lesser than 150 degrees. If you go to the Uranus, nitrogen will be in liquid form. Okay, you go beyond that, there will be lower temperature, more lower temperature. So, in satellite launching vehicle, in PSLV, GSLV, like thing, final stage is cryogenic stage. They use liquid hydrogen as a fuel, means hydrogen as a fuel, because it is purely fuel gas, and storing the gas at large volume is effective by putting in liquid form. Okay, so hydrogen expansion ratio is 850 times. 1 liter hydrogen convert to 850 liter of gaseous hydrogen. Okay, so they stored in liquid form, and it activated in above the atmosphere. Okay, that is why there is no oxidizer, means oxygen for fire. So oxygen also taken from ground. So something 20 ton of oxygen and hydrogen is taken from grounds in liquid form. So we'll just see how the cryogenic engine works. We'll use liquid nitrogen, expansion of liquid nitrogen. So I'll take some liquid in bottle. Bottle has tangential nozzles. Close the lid. Okay. Once it nitrogen convert in gas, it create pressure, and it work like jet and rotate. This is single stage expansion, single stage. They are using multi-stage turbo, well efficient turbo engine. And another thing, the fire hydrogen. So firing is more volumetric expansion. So this is yeah. Because once you cross the atmosphere, there is a very low temperature.
What about space station? उधर
You have seen
Must be.
उधर तो मतलब कुछ कूल के रहते हैं
we can create vacuum with liquid nitrogen. So
बत्ती जल जाएगी.
high vacuum systems use cryo pumping, cryo vacuum. Here are two bottles. Lower bottle has a liquid, upper bottle is empty. If we pull down upper bottle,
प्रेशर
you can say whole liquid at the bottom. Will cool upper vessel. You can say liquid is climbing up upward against gravity,
No, it's
right?
not.
So we can create vacuum with liquid nitrogen. So many systems are having cryo pumping device. They are using liquid nitrogen. Okay. Anybody heard about Seebeck effect? Seebeck effect सुना है? Seebeck effect, Peltier effect. No. Anybody know?
Sir, what was the other name? Peltier.
सी में
Is it somewhat related to junctions?
हाँ, bimetal junction.
So there is a potential difference between
हाँ.
Seebeck effect.
You're right. Tell.
Yeah, I just know that one.
थर्मो ईएमएफ
I read it, I forgot.
हाँ,
थर्मो ईएमएफ
हाँ,
थर्मो ईएमएफ
हाँ. Thermo.
So at a junction, if the two parts are at different temperatures, then there is a
देर से
current.
करंट
Bimetal junction. If we hit one end and cool
Cool
another
another
end,
end,
it will then
थर्मो
from
Thermo
hot end to
couple.
cold end, there will be electron flow.
Bend is
That creates
for
EMF
sheets.
that is called Seebeck effect.
Yeah.
And same bimetal junction, if we pass a voltage,
And
it will create hot end and cold end.
Yes.
That is called Peltier effect.
Peltier effect.
Reverse of Seebeck is Peltier. Bimetal junction is just two metals, two different metals are connected together.
Bending is when they have
This
different
simple bimetal means
coefficients.
simple thing. Bimetal
One
strip.
of them expands.
Straight strip is there. Strip straight है. If I cool down,
Now it is bending. Yeah.
actually I am not touching liquid. Liquid is much below the thing.
Okay.
We are not handling liquid. But all things cannot be done by a gloves. That is why I remove. So you can see
Arc.
this become curved, right? Because
Thermal expansion.
thermal contraction of this brass metal is more and steel is less. That is why it become bent.
अच्छा
So here is a bimetal junction,
Hmm.
and aluminum strips are connected with this to transfer the heat. Bimetal junction, and two leads are coming out to check the voltage and connected to the fan. If voltage generated, fan will be rotated. Fan will rotate.
That's water.
current be generated.
Yes. Huh? We read it somewhere, but we did such an experiment with that was thermocouple works like this only.
Thermocouple works like this because there is a
The gradient of electrons, no? The hotter end will be higher.
okay, yeah.
It will take some time to
Sure.
cool.
That one is still hot. Go. Can you get me that? No, I just wanted to see it's still hot. It started to rotate. Look at that.
You can see the direction of rotation.
Yes.
This is hot end, this is cold end. So electron flow is in
Hot.
this direction. So if I reverse it, it will change the direction. But it will take some time because now system is very cold.
What is this temperature? Not too low. Why is this again?
It's still negative temperature. It is not that.
I didn't do that. अपने आप हुआ. So there must be some limit of this voltage, right? Or like if we keep on increasing the temperature difference between,
It will also increase temperature whenever it will
will
come
it
to
keep
Voltage will be remain same.
Yeah, it will have a limit. Otherwise it can't generate infinitely high voltage using Joule expansion.
So it is for the main free path and the electrons are
Yeah.
Okay, what will happen to electric resistance if I cool down?
Will
be
decrease
decrease.
Resistance will decrease.
to a point we are not going to 4+1.
Yeah.
Just for
Depending on the
demonstration,
material.
I will bring a back.
Yeah, it is.
A bulb connected with long copper wire as a resistance and connected
Current
to
will
battery.
increase.
Bulb is quite dim. If I dip inside, it becomes bright. So resistance decreases with temperature.
Temperature.
If whole circuit is made up of superconductor, then if you just charge once,
And take it
remove
away.
the battery source, close the circuit will remain running continuously without any external power because resistance is absolute zero.
Yes.
Okay. In superconductor resistance is absolute zero. That is why circuit will remain running continuously without any power source. That is called superconductor. So
I mean, obviously.
Sorry? Yeah, but at very high pressures or low pressures?
No, not spacer, it's property, material property, not spacer depending on it. If we found, made some material like compound material, then we can find, we may find. But at this moment,
superconductor is having another amazing property called Meissner effect,
Mesner.
it will
or
float. Like to slow side.
levitation effect. So here was the small tiny superconductor made up of yttrium barium copper oxide, which superconductor at minus 183 degrees Celsius or 90 degree Kelvin. But it will take some more time to cool down. Means it is now damaged, so it will take some time to cool down. And here is a magnetic track. The effect is when we cool down by keeping packing, it will maintain that gap and run continuously.
We push it, it will flow.
The magnet orientations are like this. These are north pole, south pole, again north pole,
So
and
keep in
both ends having different magnet in different orientation. So once it reach the end, it come back. It maintains its gap. If I put something, it just run over that. Okay. And if we broke the track, it just come back at broken track. It never cross the broken track. If we tilt down, it back to vertical. If I try to rotate, it back to track direction. If I try to tilt whole track, then also it is running.
Okay.
But now it is become weak, so it will take more time to cool down. So let us skip that. So same superconducting levitation train running in Japan, Yamakaki. Train speed is 600 km/h. Just light speed you can reach at the ground. So that's it. Any questions? Thank you.